Alright, so we're moving to the next video, and in this video we're gonna talk about derivative of a little bit more complicated function than what we looked before. Before we look at the function, constant function, we look at linear function, quadratic function. Now today we're gonna look at x of t equals t cubed, 1 over t and square root of t. That's kind of the plan. We start with t cubed, and if you remember, the way we calculate derivative is we take a limit when delta t goes to 0. When we take x at the point t plus delta t, you subtract of x at the point t, that's the point where you want to find derivative at, and divide by delta t. So what it means really, we take delta t, some value, non-zero value. In fact, it doesn't really matter whether you take positive or negative value. And what you start doing is start bringing it closer and closer to 0. And you are looking at what's happening with this ratio, where this ratio goes when delta t shrinks to 0. That's what you want to find, okay? Just to clarify something, when we say delta t goes to 0, we never say that delta t equals to 0. In fact, we don't take delta t as 0. We're just making it smaller and smaller and smaller. The reason why we don't take delta t as actually 0 is because that ratio is gonna look weird if you do. Because what are we gonna do? And what happened in this case? Your denominator is gonna go to 0, and your numerator is gonna go to 0, and you really get 0 divided by 0, which we don't really know what it is. So again, we're not taking delta t as 0, we're just really making it smaller, 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 and we're looking at where this ratio goes. All right, so let's start with t cubed. So x of t is t cubed, x of t plus delta t is t plus delta t cubed. As in the last video when we talk about t squared, I told you there's a formula that I suggest you to remember. Here's another formula that's a good thing to remember. The formula is a plus b cubed. What it is a cubed plus 3a squared b plus 3ab squared plus b cubed. And that's the formula we're going to use here. In this case, our t plays the role of a and delta t plays the role of b. So we get t plus delta t cubed is t cubed plus 3t squared delta t plus 3t delta t squared plus delta t cubed. Okay? And now we gonna write that ratio that we had above in circle in blue. Okay? And that ratio will be what we just wrote, t cubed plus 3t squared delta t plus 3t delta t squared plus delta t cubed minus t cubed divided by delta t. Now, first thing you need to notice is that there's t cubed and there's minus t cubed. They cancel it out. All other terms we see here that's didn't go anywhere yet, they have delta t in them. And then as you see, we divide all of it by delta t. So let's divide by delta t each of those terms. We're gonna get 3t squared plus 3t delta t plus delta t squared. Now we simplify this ratio as much as we could. That's the first step in calculating derivatives. The next step is to see where this thing goes when delta t start going to 0. All right, let's see. The first term, Well, it doesn't have any delta t. It doesn't depend on delta t. So really, it goes nowhere and stays 3t squared when delta t goes to 0. Well, let's look at the next term. It's 3t times delta t. 3t is a constant. It's a, for each t which you choose, 3t is constant, fixed. And when delta t starts going to 0, when it's getting smaller, 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 tiny, 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 all this term, whole term is getting tiny, 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 tiny. You can check that. Eventually, when delta t goes to 0, whole thing goes to 0. And obviously, when delta t goes to 0, delta t squared also gonna go to 0. As the result, whole thing goes to 3t squared. And that's the answer. So what we're gonna say here is d dt of t cubed is 3t squared. All right, we're done with t cubed. Now let's move on to 1 over t. All right. So if x of t is 1 over t, x of t plus delta t will be 1 over t plus delta t. Now, if you remember, we need to calculate the difference between x of t plus delta t and x of t and divide by delta t. So what do we get? We get 1 over t plus delta t minus 1 over t and all over divided by delta t. Well, what's in numerator is two fractions, which we need to subtract one from another one. So what we do, we need to find a common denominator. So common denominator in the first one is going to be t, in the second one is t plus delta t, right? So what we're getting now is, well, let me take 1 over delta t out. And what we have left is t plus delta t times t. That's our common denominator. The numerator becomes t minus t plus delta t. Now notice that there's t here and minus t here. They go away. So what we have now left is, well, 1 over delta t as before, but now what we have in numerator is minus delta t. And denominator we have t plus delta t times t. Again, delta t numerator and denominator cancels out. And all we have now is minus 1 over t plus delta t times t. Now we can't simplify it anymore. We're done. And now what we need to do, we need to think where this thing is going to go when delta t goes to 0. Well, let's think about it. It's t plus delta t thing here. When delta t goes to 0, well, it goes to t. And the next term t, well, it goes nowhere because it doesn't depend on delta t. So our final answer, whole thing, we're gonna go to minus 1 over t squared. All right, so let's write the answer. You're going to say that d dt of 1 over t is minus 1 over t squared. All right. So the next thing we want to talk about is x of t is square root of t. Well, x of t plus delta t becomes square root of t plus delta t. So now the difference between them divided by delta t becomes square root of t plus delta t minus square root of t divided by delta t. And now we don't know what to do with this unless we know one formula, another formula. That's a good thing to know. And the formula is the following. A squared minus b squared is a plus b times a minus b. Okay? And now what we're going to do, we're going to say that a is our square root of t plus delta t. And b is our square root of t. So what we see on the top is that term a minus b. But we don't have term a plus b. Well, that's no problem. Let's just put them in. So what we're going to do, we're going to multiply that thing by t plus delta t plus square root of t. And now you can say, oh, wait a second. You can't just simply multiply things in math without expecting to have the same result. And you will be right. If I multiply my expression by something, so nothing changes, I have to divide by the same amount. Okay? So now, what do we get here? Well, in numerator, we get what we wrote, a minus b times a plus b, and that will be a squared minus b squared, which means it's going to be t plus delta t squared minus square root of t squared. And denominator is going to have delta t, and that term t plus delta t plus delta t. Okay? Now let's open up the top. It's going to be t plus delta t square root. Square root of t plus delta t is just t plus delta t, minus square root of t is just t. Denominator has delta t and t plus delta t plus delta t. Now what we see is there's t here, that cancels out. Then we see there's delta t in numerator, delta t in denominator. After that we can cancel them out. So what we're gonna have now is 1 over t plus delta t plus square root of delta t. So we can't simplify it anymore. What we're going to do now, we're going to think about where this thing goes when delta t goes to 0. Well, the only term we have, the way we have delta t, is here. And obviously t plus delta t is going to go to t when delta t goes to 0. And it sits on the square root. So what are we going to get? We're going to have 1 over, it's not equality, it goes to, when delta t goes to 0, it's going to be square root of t plus another square root of t, which is 1 over 2 square root of t. Okay? All right. So, our final answer is when d dt of square root of t is taken, we're going to get 1 over 2 square root of t. So, I'm done for now. We kind of work out many of the functions that we will need to use in the future. Now what we would like to do is to kind of look at what we got so far. Look at the derivatives we got and kind of think, is there a better way of calculating derivatives besides just going from the definition? When we have to calculate that ratio, take a limit, it just takes a lot of time. Can we do something more simple and easy? And that's a subject of the next couple of videos. See you then.